In high school, I achieved distinctions in physical sciences and mathematics, and I want to share my tips and strategies with you. How do you achieve a distinction? First, start by understanding the basics. For example, electric circuits are important from grades 10 to 12. If you get the hang of them in grade 10, you'll find it easier in grades 11 and 12. So, let's learn the basics of electric circuits together. I'm going to walk you through solving a typical grade 10 physical sciences question on this topic. This is to prepare you for homework, tests, or exam, and you'll be a step closer to achieving a distinction. Question 12. Let's read this question together. Learners set up a circuit as shown in the diagram below. The EMF of each cell is 1.5 volts. Each of bulbs A and B has a resistance of 12 ohm, and bulb C has a resistance of 3 ohm. Let's look at this electric circuit diagram that is given. We have a voltmeter. So this is a voltmeter. Labeled V1. A voltmeter measures potential difference across an circuit element that is connected to. So this voltmeter is connected to a battery. So this is a battery. And it means that this voltmeter V1 is going to measure the potential difference across this battery. It is important to mention that voltmeters are always connected in parallel. So this voltmeter is connected in parallel to this battery. How do you know if a second element is connected in parallel to another circuit element? Two circuit elements or three circuit elements are connected in parallel to each other if they are connected on different branches of the electric circuit. So, for example, I'm going to change the color. This voltmeter is connected on this line. So this voltmeter is connected on this line, the red line. So that's the branch in which the voltmeter is connected on. The battery, on the other hand, is connected on this branch. Let's call this the green branch or the green line. So you can see that these two circuit elements, the battery and the voltmeter, are connected on different branches. So that is why we say that they are connected in parallel. Like I mentioned, voltmeters are always connected in parallel to whatever circuit element we're trying to measure the potential difference of. This voltmeter V1 will be able to tell us the potential difference of this battery. So why is that? Circuit elements that are connected in parallel experience the same potential difference. It means that the potential difference through V1 will be the same as the potential difference through the battery because they are connected in parallel. This is why this voltmeter will be able to measure or tell us the potential difference on this battery. Next, we have light bulbs A and B. So these two light bulbs A, this is the light bulb A and B, are also connected, and they are connected in parallel to each other. Why do I say that? The same as using a similar explanation as the one we used earlier. You can see that this light bulb A is connected. Let me make that branch green. So this light bulb A is connected on this branch. Not sure why it's not writing. It's connected on this branch, the green branch or the green line, and light bulb B is connected, let's use purple, is connected on this line. So these two circuit elements, the light bulbs A and B, are connected on separate or different branches of the circuit, the green line and the purple line. This means that they are connected in parallel. What did I say about circuit elements that are connected in parallel? I said that circuit elements connected in parallel experience the same potential difference. It means the potential difference at A will be the potential difference at B. But look there below. If you check below these two light bulbs, you see there is another circuit element there. So let me just write light bulb quickly. It's important to learn the names of these circuit elements. So this is a light bulb, and to also know the spelling. In physics, we not just learn the physics, we also need to learn the correct spelling so that those two are your light bulbs, right? As I've mentioned, there's another circuit element. I like the color blue. There's another circuit element underneath or connected to the two light bulbs, and that is the voltmeter V2. So this voltmeter V2 will measure the potential difference of these light bulbs. And that potential difference V2, you see, it is also connected in parallel. It is on a different branch or a different line, the blue line, than light bulb A or light bulb B. Circuit elements connected in parallel experience the same potential difference. So this light bulb, this voltmeter V2 will be able to measure the potential difference across A and B because they'll have the same potential difference. And all of them are connected in parallel. This is a parallel connection. Now, next we have light bulb C. But before I talk about light bulb C over here, I want you to imagine that I was replacing light bulb A and B with one light bulb. So light bulb A and B, I'm replacing it with one light bulb. Let me call that black. Let me call this light bulb P. So I want to replace this light bulb A and B with another light bulb P. P for parallel. And if I do that, next to this light bulb P, I would have light bulb C. So PC. You can agree. So I've replaced these two light bulbs A and B with a single light bulb P for parallel, for the parallel connection. And you can agree with me that if I do that, light bulb P is now connected in series with light bulb C. So because they are on the same branch, light bulb P and light bulb C are on the same branch, it means that they are connected in series. So light bulb C is connected in series to the parallel connection of these two light bulbs together. Hence, they are on that same line or the same branch. Now, if we go a step further, you can also see that underneath or next on light bulb C, there is connected a voltmeter. That voltmeter is labeled V3. So this voltmeter is again connected in parallel to light bulb C. As I've mentioned, voltmeters are always connected in parallel. So this light bulb C is in this line or branch, and now the voltmeter, which color haven't I used? Let me see this one. And now this is now connected on a different branch as well, depicted by the different colors, right? So it means that they are connected in parallel and they will experience the same potential difference, meaning that voltmeter V2 will be able to tell us what is the potential difference across light bulb C. I hope that you are still with me. Last, we have a switch. So when a switch is drawn like that, there we have a switch S. You can see it's a switch. So a switch, as you know, you can turn it on or off. So when it's drawn like this, where you have something like this, it means that the switch is open, meaning it is off. Sometimes they will just draw it like this when you close it. So the switch is closed, meaning it is on. When it's drawn like this, it means that the circuit is incomplete. The circuit is incomplete. And that essentially tells us that there is no charge flowing in the circuit, meaning there is no current. So that is an important thing to understand. If the switch S is open, it means that there is no charge flow, meaning that there is no current in the circuit. So now that we have analyzed and we know what each of these electric or circuit elements are, the voltmeter, the light bulbs, and the switch are, we are in a position to answer the questions. It's important for you to also know how to draw these symbols. Look at the symbols for the light bulb. Look at the symbols for the voltmeter. Look at the symbol for the battery, right? It's very important for you to know how to draw those circuit elements. So let's go to question 12.1. Calculate the effective resistance of bulbs A and B. And this is a 3-mark question. So how do we go about calculating the effective resistance? And what does effective resistance even mean? So I'm just going to erase this quickly. When we talk about effective resistance, we are talking about the total resistance in that part of the electric circuit. So light bulbs have a resistance. Light bulbs have a resistance, and that resistance was given to us here. So they want us to determine the effective resistance here. That is the total resistance. So you might be thinking, why? Why is that important for you to know and for you to understand? Just because each of the light bulbs has a resistance of 2 ohm doesn't mean that their total resistance is going to be 4 ohms. If they were connected in series, yes, but if they are connected in parallel, their total resistance will actually be lower. So that's why they are now asking us to calculate the effective resistance. I want you to think about it as they want you to replace those 2 light bulbs with 1 light bulb that we called P earlier. And that light bulb, we now have to determine what the resistance of it will be. To do that, there's a very nice formula. Let me change the color to red. There's a very nice formula. Typically, you are given the formula at the back of your question paper, but it's always important to know and understand those formulas. That formula or expression says 1 over Rp. P is for parallel for this light bulb P, which represents the effective resistance of light bulb A and B. 1 over Rp equals to 1 over Ra plus 1 over Rb. Right? Rp is the resistance that we're trying to solve for. We want to know what is the value of that. Ra is the resistance on light bulb A. Rb is the resistance on light bulb B. What did the question statement say? What were we given? We were given that the resistance of A, let's go, equals to the resistance of light bulb B. And how much was that value? Do you remember? That value, they said each of bulbs A and B has a resistance of 2 ohm. So those two light bulbs have the same resistance, 2 ohm. Now that we know the values, it means we can just substitute those known values there. So remember, resistance is measured in ohms, represented by this symbol here. This is the Greek symbol called omega. It's a capital letter omega. So there's this song, Ke Alpha Le Omega. It's a gospel song for those people that speak Sesotho. So typically alpha is the first letter of the Greek alphabet, and omega is the last letter of the Greek alphabet. So the beginning and the end. This is so that you remember this, the name of the symbol omega, that we use resistance, that we measure resistance in, right? But let's move on. I'm getting distracted. So we know the values of RA and RB. So it means that we can just say 1 over 2 plus 1 over 2. Remember, on this side, we still have 1 over RP. So we go 1 over RP equals to 1 over 2, which is a half, plus 1 over 2. A half plus a half, so a half plus a half. How much is that? You need to be able to do this from the top of your head. How much is that? 0.5 plus 0.5, that is 1. So it means we actually now have 1 over RP equals to 1 over RP equals to 1. But immediately you can see this RP is still at the bottom. There's many ways of doing this. Some people may cross multiply, but for me, the easiest way is to write both the left-hand side of this expression and the left-hand side, the left and the right-hand side as a fraction. Remember, a fraction has a numerator and a denominator. So for the left-hand side, the numerator is 1, the denominator is RP. Remember, when you are writing, you don't necessarily need to include all of these steps. I'm including them so that you understand where some of the things come from. So you have 1 over RP on the right-hand side. The numerator is 1. 1 divided by 1 is 1. So I can also write that the denominator is 1. Right? I hope that is clear. And from this, I can just swap there on both sides. What you do on the left, you also do on the right-hand side. I can swap the denominator for the numerator and the numerator for the denominator. Similarly, I can swap the numerator for the denominator and the denominator for the numerator. If I do that, then I know I'll have RP over 1, which is equals to 1 over 1. RP divided by 1 is just RP. 1 divided by 1 is 1. This means that the value of RP equals to 1 ohm. I hope that is clear. So now we have found the effective resistance of those two light bulbs. Because they are connected in parallel, their effective resistance is much lower than the resistance that they actually each have. It's very interesting that when we add those resistors or light bulbs in parallel, their resistance, their total resistance actually decreases. So we are done with that part. We've calculated that. So where are the marks coming from? You'll get a mark for the formula, right? You'll get a mark for the substitution, and you'll get a mark for the final answer. The other steps in the middle, you will not get a mark for, but I have included them so that you understand, as I always mention, where all of these values are actually coming from. So now let's go to the next question. The next question requires us, or the next question says, switch S is now closed for a short time. 12.2. Determine the reading on 12.2.1 voltmeter V1. So what is the reading on voltmeter V1? Where is voltmeter V1? Here is voltmeter V1. So what is the reading there? This is a very interesting question and it carries very little marks, but I'm going to spend some time explaining it. Remember, in grade 10, we're learning the basics. If you understand these basics, grades 11 and 12 are going to be much easier for you. So, to answer this question, we first need to understand this statement here. The EMF of each cell is 1.5 volts. What is an EMF? What is the definition of an EMF? This is a definition that you may be asked. Sometimes they don't necessarily ask you, they just use it in a sentence, but you need to know the definition of that. So when a circuit, an EMF is a potential difference. But it is a potential difference when we say the circuit is incomplete. When there is no charge going in the circuit, there is no charge flow in the circuit. Why wouldn't there be a charge flow? Because the switch S is open. So this EMF tells us what is the potential difference there of the battery when charge or there is no current in the external circuit. The moment you close this switch, we no longer refer to it as the EMF, because remember, the EMF is just the potential difference of the battery. We now talk about something called terminal potential difference. So let me write this down. So we have an EMF, which is potential difference. I'm going to write PD, potential difference when circuit is incomplete. There is no current or there is no charge flow in the circuit. We also talk about terminal potential difference. It is the potential difference of that battery when the circuit is now complete. Now, in this example, they don't mention anything about something called internal resistance of the battery. I think you will learn about this in grade 11. So they don't mention anything about this. And because they haven't mentioned anything about it, it means we can make an assumption that the EMF in this instance is also equals to the terminal potential difference. In grade 11 or even 12, they will talk about internal resistance. You'll realize that typically when you have internal resistance, battery resistance, the EMF will be higher, slightly higher than the terminal potential difference. But like I mentioned, here we're going to assume that both those two values are the same, because when the switch is closed, you are now talking about terminal potential difference across that battery. When the switch is open, we are talking about the EMF. Be able to differentiate between those two values. But this, we are not just done by now understanding what is an EMF. There's another important thing here, that if you miss it, you're going to get the rest of the answers wrong. They talk about a cell. They saying one cell or a cell has an EMF value, which is also the terminal potential difference of 1.5 volts. What is the difference between a cell and a battery? What is the difference between a battery and a cell? So a cell is made out of a collection of cells. Sometimes these two words, a cell and a battery, are used interchangeably. So it's always important to be aware. We may sometimes a person will be referring to a cell and call it a battery, but they're actually not the same thing. So a cell is made out of a collection of cells. So the symbol for a cell is this. We have those vertical lines, a long one and a short one. Remember, the long one is the positive, the short one is the negative. This means one cell. When we start stacking, connecting these cells together, as in the question, I think they have about 4 of these cells. They have this cell here, 1. They have another cell here, 2. Another cell here, 3. Another cell here, 4. Then we get a battery. Let's have a look. Look here. So we have a cell here, 1. Another cell here, another one here, 3, another one here, 4. So how many cells in total do we have? We have 4 cells. So my question is this for you. If one cell has a potential difference of 1.5, how much would this battery's potential difference be if it is made up of 4 cells? You've guessed it. It will have a value of 1.5 multiplied by 4. What is 1.5 multiplied by 4? That is 6 volts. I like this question. So when you start understanding this, you can just immediately answer this question from the top of your head. You can say, okay, one cell is 1.5. This battery is made out of 4 cells. So that's 1.5 times 4. It means the answer to question 12.2.1 is, right, 12.2.1 is 6 volts. And you'll get a mark. So what is the takeaway from this? You need to know what is a battery, and a battery is made up of a collection of cells. Right? So now let's go to question 12.2.2. They are telling us that before we go there, this means that this voltmeter will measure a potential difference of 6 volts. So from here, we know that V1 equals to 6 volts. Now, 12.2.2 says, determine the potential difference, or the value, the reading that the voltmeter V3 is going to measure. So determine the reading on voltmeter V3. That is a 2-mark question. Yes, it's 2 marks. It means you're not going to be spending a lot of time on it, but I'm going to make my explanation slightly more extensive so that you master, you understand those basics. You learn in the basics. By the time you get to grade 11 and grade 12, you'll just be flowing, right? So what is the reading on voltmeter V3? How do we answer this question? To answer this question, we need to remember, I said to you, we can replace the light bulbs A and B by one light bulb, which we determined its resistance to be. I'm going to write Rp equals to 2 ohm. And this light bulb P is connected to light bulb C, which is in series. And they said that the resistance of light bulb C, how much was it? In the question, it was given to us as 3 ohm. So Rp equals to, I am lying. Rp, we said it is 1 ohm. Apologies. 1 ohm. So RP, it's not RP here, it's RC. So RC equals to how much? 3 ohm. So these two are connected in parallel. I've replaced these two light bulbs that are connected in parallel with one light bulb which has an effective resistance of 1 ohm. The most interesting thing about circuit elements that are connected in parallel is that they share, or they split, or they divide the total potential difference. So you'll hear maybe in books they are called potential dividers. Circuit elements connected in series are potential dividers. This means that these two light bulbs will divide the total potential difference from the battery, which we determined here is 6 volts. So how will they share it? How do I know how much will this light bulb P have and how much will this light bulb C have? They share it proportionally. It's a very nice word, proportionally. You're going to meet this word a lot. This value is directly proportional to this value. This value is inversely proportional to this value. So you might as well get acquainted with it. So when I say that they share it proportionally, according to the ratio of the resistances. What do I mean by that? I mean, if we take the ratio of the resistance of light bulb P, which is 1, we see that the ratio is 1:3, because this light bulb P has a effective resistance of 1 and light bulb C has a resistance of 3. So their ratio to each other is 1:3. But what does this mean when I say it? This means that if now light bulb P has a potential difference of 1 volt, now light bulb C will have a potential difference of 1 multiplied by 3, 1:3, meaning it will have a potential difference of 3 volts. If now light bulb P has a potential difference of 2V, light bulb C will have a potential difference of 2 multiplied by 3, which is how much? 6 volts. So that's what I mean when I say they will divide the potential difference proportionally or proportionately, right? But I still haven't answered the question. How do I then determine the potential difference here that this voltmeter V3 is going to measure? With the reading on it, I will say, okay, I'll say voltmeter V3, the potential difference across light bulb C is going to be equals to the total potential difference, which we found to be 6 volts, that is measured by voltmeter V1. So that's why I'm writing voltmeter V1, multiplied by the resistance on light bulb C divided by the total resistance, which is RC plus the resistance of the parallel connections. So then we just substitute the values that we know. We have 6 multiplied by what is the resistance on light bulb C? We said that resistance is 3, isn't it? Yes. And then RC3, what is the resistance on RP? It is 1. So we have 6 times 3. How much is that? 6 times 3 is 18. And then 18, 3 plus 1 is 4. It means we have 18 divided by 4. How much is that? You can put it on your calculator. You're going to find that value to be 4.5 volts. I hope that is clear. We can also use the same formula to say, okay, how much would then V2 read? What would be the reading on V2? So before I move ahead, you're just going to get a mark, 2 marks for this question. I was just showing the steps so that you understand where that value comes from. You don't get the marks for the, what is this, for the calculations according to the memo. So we can do the same thing for V1. We can say V1, V2, I'm lying. V2, the potential difference across the parallel connection is going to be the total potential difference, which is V1, multiplied by what is the resistance RP for the parallel connection, divided by the total, which is RC plus RP. And if we do that, we have 6 multiplied by 1 over 3 plus 1. How much is that? So you have 6 times 1, which is 6. 6 times 1, which is 6. 6 divided by 4, it's going to give us a value of 1.5 volts. And now you see that if we remember, I spoke about that 1:3 ratio. So if the potential difference on V2 is 1.5, it means that the potential difference on V3 is going to be 1.5 times 3. And this is equals to 4.5 volts. So that is how you can go about determining that potential difference. There's another way, of course, of doing this. That's the nice thing about physics. There's always different ways in which to solve problems. Some people first go determine the current, but I feel like for a 2-mark question, that is a very long route to doing it. But if you understand that method, then by any means use it. Why did I show this specific method of solving this problem? Because then you start understanding this concept that circuit elements that are connected in series will share or split or divide the potential difference. That's why they are called potential difference. And they will divide that potential difference depending on the magnitude of their resistance value to each other, depending on the ratio of their resistance values to each other. If you start practicing this over and over again, it will start to make more sense, right? So now let's go to question 12.3. Question 12.3 says to us, calculate the energy transferred in bulb C in 3 seconds if the current in the circuit is 2 amperes. It's 5 marks. So typically when you see a question there with 5, 6 marks in physics, one, it should tell you that you are most likely going to use 2 equations or 2 formulas or 2 expressions. So how do we go about it? We first say, okay, what is given to us? We are given that the current I equals to 2 amperes. We are also given that the change in time, or delta t, this triangle is the Greek letter, delta, is 3 seconds. That energy is transferred in a time frame of 3 seconds. What else are we given? We are also given, it's not given on the statement, but we know because we are concerned with this bulb C that the potential difference there at bulb C, we've calculated it previously as 4.5 volts. So what can we do with this piece of information? One, when we talk about energy transferred, this refers to work that is done. And what is the symbol for work that is done? It is capital letter W. So we need to find capital letter W when we are given all of these values. What is capital letter W? What is the work done? And that work done is measured in joules. So how do we go about it? Remember, now it's important for us to remember, how do we define potential difference? Potential difference is defined as the work done per unit charge. Mathematically, it's written as V equals to W over Q. V is the potential difference. We say V free because we are concerned with light bulb C, and that light bulb C, its value is given by that voltmeter V free, which is equals to the work done over the charge Q in coulombs, right? So we want the work done, we have the potential difference, but we don't have Q. How do we find Q? But before I tell you how do we find Q, we can use this triangle to rearrange the terms. So it says V free, so we'll say V equals to the work done. It's in the numerator, so I place it at the top, divided by Q is in the denominator, so I place it at the bottom. And now I'm looking for the work done. The work done is just going to be W equals to V multiplied by Q. V multiplied by Q. And this is V3. We know what this is. We don't know what this is. So how do I find Q? You find Q by remembering, oh, I'm given the current and the time. If I'm given the current, I can actually determine the charge. How so? There's an equation that says the current equals to the rate of flow of charge. So mathematically, it just means that I equals to Q over delta T. But still, even in this instance, I am looking for this guy over here, Q. How do I make that guy to be the subject of the formula? I use again the triangle. I say, okay, it means I equals to, because the Q is on top, it's going to be there at the top. It's in the numerator. Delta T is at the bottom, is in the denominator. So what is Q? Q is just going to be I, both of them at the bottom, I multiplied by delta T. So now you say, okay, if I have the work done, I have the potential difference multiplied, I can actually just, in the place of Q, write I multiplied by delta T. And I have V3, I have the current, I have delta T, I'm done. I can just do the calculations, right? So you say V3, what is the potential difference? We said it's 4.5 multiplied, what is the current? The current is 2 multiplied by the delta T, which we said it is free. Let me double check. Yes, 2 times free. And then there you are. Like, oh, okay. How much is 2 times 3? That is 6. 6 multiplied by 4.5. That's going to give you a value of about 27 joules. So now you have solved for this problem. And it is 5 marks. So how is the mark distribution? One important thing that you'll get a mark for is your understanding of this formula, of the charge formula. Let me just erase that quickly. So you'll be given a mark for the formula, I believe. Then you'll be given a mark for this calculation here of the current and just the correct overall substitution in the final mark, right? So you have 1, 2, 3, 4. I would like to believe that the last mark will be from here. So there you have your 5 marks. The final question is then going to be 12.4. It says, all the bulbs are now connected in parallel. How will the total current in the circuit be affected? Write down only increases, decreases, or remains the same. So I'm going to explain first so that you understand my answer. Somebody might already know the answer from the top of their head. But for those of you that are like, I'm not quite sure. They're saying they now connect all of these light bulbs in parallel. So you're going to have a situation like this. right? So all of these are now connected on different lines or branches. This branch, this one, and this one. So this is C, B, and let's say this is A. So now they're saying, what was the question again? How will the total current be affected? So using this, it means you can find the effective resistance by saying 1 over Rp is going to be 1 over Ra plus 1 over Rb plus 1 over Rc. And we just substitute the known values. Remember, when you're writing, there's no need to include all of these steps, because by the time you write, you will know how will the total current be affected. So if 1 over 2 plus 1 over 2 plus 1 over 3, how much is that? So 1 over 2, we can use a calculator. And when we use that calculator, you'll find that 1 over Rp is just going to be 4 over 3. So the same way in which we did the problem earlier, we just swap the numerator and the denominator and vice versa. And then we end up with that Rp over 1 is going to be 3 over 4. This means that Rp is going to be equals to 3 over 4. That is actually just 0.75. So check how the total resistance, the total effective resistance has decreased to the value of about 0.75. So if the total resistance has decreased, what would happen to the current? So there's an expression by Ohm's law, and it's something like this. And this expression just literally tells us that R, which is for the resistance, equals to the potential difference V divided by the current. This essentially tells us that because this one is in the numerator, if we were to make this side a fraction, you see this is in the numerator and this is in the denominator. It means they are inversely proportional, right? So if they are inversely proportional, so the resistance is inversely proportional to the current. If they're inversely proportional, it tells us that if this one increases, this one is going to decrease. And if this one decreases, if the resistance decreases, the current is going to increase. In this instance, the current decreased from a value of 4. Remember, we calculated the total current, the total resistance as 1 plus 3. This, which was 4. It has decreased from that value to 0.75. If the current has decreased, it means that if the resistance has decreased, it means that the current has increased. So we'll say the correct answer is increases, because, but you will only write the answer. But the reason is that the resistance is inversely proportional to the current. So let's see, we've come to the end of this question. If you solve that question correctly, you would get about 12 marks. I wish you all the best in your studies. One of the ways to achieve a distinction is to believe that you can. It starts there. Stop listening to people saying physical sciences is difficult and all of that, because it's just going to discourage you. Make sure that you believe. Even if you didn't do well in the first term, you have the second term, you have the third term, you have the fourth term. Even if you don't do well in grade 10 and you are able to go to grade 11, I promise you, if you are consistent and persistent, by the time you get to grade 12, you are going to get that distinction, right? Thank you so much for watching. Tell me what you think. Tell me how you would go about solving some of this problem, and tell me if you found them helpful. Thank you.